Hello everyone, welcome back from the weekend. We are going to be talking about lesson 213 today, which is more transformation stuff concerning parabolas. All right, content goals are typically the same for the early part of this unit. In each lesson, we're going to be learning how to transform a parabola. We're just going to be learning different variations of it in different situations and scenarios in which we're going to transform those parabolas. Okay, but we're going to talk about graphing form, stretching, horizontal shifting, vertical shifting, and reflecting, just like we have in the previous lessons. We're going to start off with some completing the square. This will be on the quiz this week, so we need to make sure that we have this down. We started talking about it last week, but we want to make sure that we definitely have it down by the end of this week. All right, so we have a quadratic given to us here in its standard form. And when we talk about that standard form, we mean that we have those three parts being added, right? The x squared, the x, and the constant. They're all being added or subtracted in some fashion. That's how you know you're looking at standard form. Our goal is to get into graphing form, which looks like this down here, where we have the parentheses squared with a plus some number on the end. Okay, and the way that we do that is we use this method called completing the square. Okay, so I'm going to draw my box. I'm going to divide it into 4 compartments here. All right, and then I take the x squared and it goes in the upper left-hand box, just like that. And then I take this middle term and I'm going to cut it in half, right? So if I take 4x and I chop it in half, I get 2x, right? So I'm going to put 2 x's here, and I'm going to put the other 2 x's over here, filling in that first diagonal. All right, now we're going to leave this box alone for right now, and what I'm going to do is I'm going to start filling in the outside dimensions here. I like to switch colors when I do that. Okay, so thinking about this x squared, to get x squared, we need to multiply x and x, right? So x times x gives me x squared. And then to figure out what number is going to go here on the left-hand side, I need x times whatever number goes here to give me 2x. Well, that's got to be a 2. X times 2 gives me 2x. And I'll get the same thing over here. X times something gives me 2x. That has to be a 2 as well. So now I'm going to start writing my equation here. And again, I'll come back to this bottom right-hand box in just a minute. But notice that we have the length and the width of our overall rectangle already. So I can start writing my equation. So I can say y equals, and I'm going to write my parentheses, and I'm going to say x plus 2 squared. And the reason that I can say it's squared is because it's x plus 2 times x plus 2. Both sides are the same. So x plus 2 squared is the same thing. All right. Now I'm going to go ahead and fill in the rest of my box here. If I do 2 times 2, I get a 4 in the bottom right-hand box. All right. But if you notice in our equation, we really needed a negative 5 to be there. Okay. So if I just do x plus 2 squared by itself, I know I'm going to get a 4 on the end, but I need a negative 5. So I got to think, how do I go from a 4 down to a negative 5? Well, I'm going to have to subtract 9 off the end, right? If I do 4 minus 9, it takes me down to the negative 5 that I need. So I'm just going to subtract 9 on the end. And now if you look at this equation, it looks a lot like our graphing form that we wanted to get to down here. All right. You'll notice that the a value is not out front here. That's because it is a 1. And you'll notice that there is a 1 in front of that x squared as well. Okay, so we don't have to worry about the a value here. It is going to be 1. Now, the next thing they want us to do is identify the vertex. So once we're in this graphing form, we should be able to see our vertex by looking at 2 numbers. This one and this one, right? This is our h value, which controls our horizontal left and right movements, right? And the negative 9, which controls our up and down. Okay, so we are going to write our vertex. Since this is a plus 2, our vertex moved to the left 2, so it's going to be located at negative 2. And this minus 9 means that my vertex moved down 9 units. So it's going to be at negative 2, negative 9. So there's my vertex, there's my graphing form, and there's the standard form from which I started. All right, guys, so that is completing the square, and reading the vertex from the equation. And in the notes here, what you will see is just, again, that summary of what we talked about last week, how each part controls a different type of movement and how it does it here in the far right column. Don't forget about reflections. Remember, to do a reflection, you got to put a negative in front of the A value, but make sure that you review this constantly. This is kind of the most important thing when it comes to these transformations, is that A, H, and K value and understanding what they do. All right, so what we're going to focus on today is finding the stretch factor in different forms. So that stretch factor meaning we're making the parabola skinnier or wider in the graph, and you can actually find that stretch or compression factor pretty easily from the equation no matter what form you're in. All right, so graphing form, it's real simple, right? We just look at that number in front of the parentheses here. That is our A value. So we would say that our stretch factor is 3. Right, we just look in front of the parentheses. Now in standard form, right, it doesn't look like graphing form, so you might think, well, I don't know where to look for this, but the A value is located right here. It is always going to be that number in front of the x squared. So if you're in standard form where everything's being added and subtracted, you just go to that x squared term and you look in front of that x squared, and whatever number is there is your stretch or compression factor. So this is going to be a parabola that's a little bit wider because it's being compressed by a factor of 1/2. Now in factored form, there's actually a couple different places that we can look for the stretch or the compression factor. One place is out here in front of the parentheses. So you'll see this 2 that's kind of hanging out in front of our 2 parentheses. That is a stretch or compression factor. So in this case, this parabola has been stretched by a factor of 2. Okay, so let's try it again. So this seemed to confuse some people on the tests last week. You'll notice here in our graphing form where we would find our stretch factor, there is no number right here, right? There's nothing in front of the parentheses. And when that happens, we assume that it's a 1. It hasn't been stretched or compressed at all if the stretch or compression factor is 1. Okay, so they don't usually write a number here if it's just a 1. Now, over here in the standard form, again, we would look in front of the x squared, and you'll notice there is no number, but there is a negative, right? So that negative indicates that it's been reflected, but again, there's no actual number here, so we get to assume that the stretch or the compression factor is, again, 1. Okay? We're not going to put -1. The negative actually doesn't do anything for stretch or compression. It only flips the parabola up or down. All right, now, the tricky one here. Okay, so this one is our factored form, and I had shown you in this one that we're looking at that number in front of the parentheses, but there is no number here. But also notice that there is a difference because I put a 2 here and a 3 here, and there were no numbers in front of the x's in this one. So to figure out what the stretch or compression factor is here, I need to take 2x and multiply it by 3x. So I've got to multiply those first 2 terms in the parentheses there. So if I do 2x times 3x, what I get is 6x squared. And then I can look at that number attached to the x squared, and I can see that my stretch factor is 6. So that is finding your stretch or compression factor from several different forms and several different scenarios. You'll have a daily practice problem that's going to do kind of the same thing. All right, so make sure you give it a try. Make sure you can find the stretch or the compression factor in any of those scenarios. Okay. All right, last problem we're going to talk about today is just writing the equation of a quadratic given the graph. Right, we've never gone in this direction yet, so we've never started with a graph of a parabola and been asked to write the equation strictly from the graph. I've given you a description of the transformations and asked you to write an equation, but never just the graph. All right, and notice here, this is a very key piece of information. It says you may assume, oops, and I cannot write today. You may assume that the stretch factor is 1 or -1. Okay, this is important because they're essentially giving us a piece of information for our equation right off the bat. All right, so we don't have to worry about that stretch factor in the graph. All right, so it says use the graphing form that I've given you, and here it is. I've already written it down, and so our goal is to find A, H, and K by looking at the graph. Okay, and we already know what A is going to be. A is going to be 1, right? Because it said it's either going to be 1 or -1. I just need to figure out if I put a negative in front of that 1 or not. Okay, and I can tell whether or not I'm going to put a negative in front of that by the direction that the parabola opens up. This parabola is opening up downwards, so that's telling me that it's been reflected, so I do need a negative in front of that 1. Now it says x minus h. Okay, well, let's see what happens here. So this parabola, now normally, if this parabola hadn't been moved left or right at all, the vertex would be located right here. Okay, this is where the vertex would be if it hadn't been moved left or right or up or down. It'd be sitting on the origin. But this one is not, right? It has moved to the left. 1, 2, 3. Okay. You can see that it's moved from the origin to the left 3 units. And to move left, I need a plus 3. And I close my parentheses and I'm going to put a square on it. Then the plus k, right, that's my up and down movement, so I got to look, well, if my parabola started here, did it go up or down? And it did go up. It actually went up 2, right? So if I look at how high it went up there, it went up 2. So I know to move up 2, I need a plus 2 where the k value is. So this becomes the equation of my parabola. So again, it's handy just to go through and make sure that you can find these 3 things by looking at this graph. There's going to be a left and right movement, and remember, all parabolas start here. Okay, they start at 0, 0. So if the vertex is over here, then you know that it's moved. If it's over here, you know that it's moved. All right, you just got to figure out what was the horizontal movement, what was the vertical movement. All right, guys, that's it for today. Give the practice problems a try. Let me know if you have questions in the Zoom chat. Have a great day.